With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is given as so this is the main question, and about this question we were given this paragraph. So let me read this first. So boron is an electron deficient compound. Yes, that is electron deficient compound. It has only 6 valence electron. So the boron atoms lacks an octet. Next, acquiring an octet driving force the unusual bonding structure found in the boron compounds. As an electron deficient compound, BH3 is a strong electrophile. Yes, this is a strong electrophile which can gain the electron from the nucleophile, capable of adding to the double bond. So it can add to the double bond as well, because double bond itself acts as a nucleophile. Now this hydroborations of the double bond through the occurs one step with the boron atom adding to the less highly substituted end. Means from the late highly substituted end we have to add the boron to the double bond. In the transition state, boron atoms withdraw the electrons from the pi bond and carbon at the another end. The double bond acquires a positive charge, partial positive charge. This positive charge is more stable on the more substituted, highly substituted carbon atom. The second step is the oxidation of boron atoms, removing it from the carbon and replacing it from the hydroxyl group by using H2O2 OH negative. The simultaneous additions of boron and hydrogens to the double bond leads to syn addition. Syn means same set of addition will take place. The oxidation of tertiary alkyl boron replaced with the boron with the hydroxyl group is the same stereochemical. Same stereochemical means when the boron will be removed and hydrogen will be OH will be added, so that will be from same side. Now, thus the hydroborations of alkene is an example of stereospecific reactions in which different stereoisomer of the starting compound, means this is a different stereoisomer of the initial compound reacts with the different stereoisomer of the final products. So that means reactant will be a stereoisomer of some product, some compound, and product will be also a stereoisomer of the another compound. Now first of all, what will happen, this pi bond will be act as a nucleophile and that will be donated to this boron, and 3-member ring transition state will be formed. So that we can write here. These are the options that we will be given, A, B, C and D. So these are the options. Now first of all, we can make this a structure in that way. So we have something like this bonding here. Okay, now next, this is presented here, and here pi bond is present. So what will happen when this pi bond will be break, this boron will come to that, and both the D group are present on the same side, that is alkene. We can say this is a cis form because both the same group present on the same side. Now this boron will approach to this alkene, and in that time what will happen, in that time that this pi bond will be break and partial bond will be formed. This partial bond will be formed, in that way transition state can be shown. Now this carbon will have a partial positive charge as it is written. So less substituted carbon will attach to the boron, but here both the carbon are same substitution, so we can take this boron with any of the carbon and hydrogen will be added to one carbon. So let's suppose this hydrogen is added to this carbon, so this bond will be break and boron will be added to this carbon. So in that way, the next step we can show something like this. Means this is the structure that we have given, and here we have added as a boron, so it will be BH2, means one hydrogen is transferred to the another carbon, adjacent carbon in the pi bond, and here we have this D. So both the D will be present on the same side. Now we can assume this entire molecules as a R, because it will be difficult to write again and again. So this as a R, so RBH2 is there. Now another, if you take another mole of this alkene, and again this BH2, RBH2 will approach. Now initially it has a BH3, now it has a BH2. So from BH3, as we can see, one hydrogen is added to this compound, and this compound is connected with the boron. So that means if you use 2 moles of this compound, so 2 hydrogen will be replaced and 2 R group will be come here. So that means we are using alkene, 2 moles of alkene and the same alkene. So in that way, 3 moles of this compound as a, no, not 3 moles, actually 3 alkyl group. 3 alkyl group will be added to this boron. Now in the next step, what we have to take, in the next step we have this H2O2 and in basic medium. So what will happen, this bond will be break and this bond will be break and this bond, 3 bond, and OH oxidation will take place. It is written that In the last step, oxidation will take place and OH will be added to R group and this boron group. So in that way, 3 moles of this ROH will be formed and 1 mole of BOH3 will be formed in that way. Now, this OH will be added to which position? That is a question. So this OH will be added to this position because this carbon and boron has a bond and this bond is breaking here. As we can see here, boron and carbon bond is breaking. So this bond will be break and in that position OH will become. So that means that OH and H will be of same side. Means when the addition will take place, so both the group will be present on the same side. Remember that because at is event the same additions and same stereoisomer. So that means both will be added in the same side. So let's suppose if D is here, so we can show D is here and OH and H. So as we can see here, chiral center is present. Here also chiral center is present. And another thing is that it can form two products because this is not the symmetric molecules. And if it is not symmetric molecules, so this will be optically active and it will form a racemic mixture. In case of optically active, it will always form racemic mixture. So we can take one mirror image of this compound and that mirror image will be the racemic mixture of each other. So that means enantiomer of each other. So option B will be the right option. So I hope you understood this concept. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.